This homework problem originally only involves looking at a discrete probability distribution and examining for discrimination. We're going to take another look at this problem under a different lens. What we're going to do is collect simulated samples of 12 jurors from this population over and over and over again to see just how many of those have 6 jurors or potentially fewer, which would be even more extreme. We would see here that there's a pretty low probability of 6 jurors. And if I plug this into Applet binomial using let's change this was 76% and 12 jurors, then I can see the resulting distribution here really weighs heavily on this large sample of Mexican American jurors. We would expect about 3/4 of those, or 9 out of 12, to be the most common makeup of a jury of 12. That would be pretty close to the 76%. We see that it's also pretty likely to be a little higher than that or a little lower than that. We could even consider going 2 standard deviations above and below the mean, which is about 3 to get a usual range. So from 9 going up to 12 and as far down as 6 would give us a pretty typical range of results. Because the 6 and 12 are kind of right on the margins of that, it helps to use probability to really figure that out a little more specifically. Here I can see that I've highlighted about 99% of outcomes. So that might even be including some pretty rare events here with the 6 and the 12. So sometimes what we'll do is we'll look at that exact probability. We'll show that this specific result has only about a 3.4% chance. Or looking at this as a tail, where we say, what's the probability of a jury that's like this one, or even more extreme, or even underrepresented? Sort of pooling those together and showing that really anything in this range is under a 5% chance. Oftentimes when we see a tail like that has under a 5% chance, what we say is that any result in that tail is relatively unusual in this distribution. So with only about a 4.5% chance of getting a jury of 6 or fewer, and we had 6, we would conclude that, yeah, it does seem like maybe some discrimination occurred, although it would depend on what we consider the cutoff or reasonable doubt. Sometimes we'll call that a level of significance. If our level of significance was only 0.5%, this wouldn't be enough. If our level of significance is 5%, it would be enough. That gets into the concept of hypothesis testing. Now, this is just a theoretical distribution of what we expect and what percentage of the time we expect it to happen. This is not the same as a simulation. I'll use a Rossman chance applet collection, one proportion applet, to simulate this situation. If you just look at the entire Rossman chance app collection, you won't find this in this list. I recommend going to Reese's Pieces, which is a qualitative or categorical type of simulator. And if you scroll down to Spinners here, this is the most generalized version of it, where we can put in our probability of success of 76% and do 12 spins to kind of figure out what it would be like to select 12 jurors from this population using a spinner. And here it's kind of just randomizing it with that given percent. Now, for the most part, I don't really need to see these animations. Usually I'll uncheck that box and I will also hide them here. The main thing I want to know is the result. This is just one simulation and I've got 9 successes out of 12. That's going to give me a 75% chance, which I could look as a proportion here or a number of successes here. I'd like to have a total of 10,000 of these simulations, so I'll put 9,999 more, which should give me a total of 10,000 there. It'll show me the most recent, which was a 50-50 jury. That's actually the one they were asking about. They wanted to know, is it likely that we get this jury that's 6 out of 6 or 50% consisting of Mexican American versus the population, which is actually 76%. Now within our 10,000 samples, we can see some stats here. We've got an average number of Mexican Americans of 9.1. Comparing to the binomial, that should be pretty close, because with the properties of sampling theory or sampling distributions, the mean of the sampling distribution, which is what we're looking at here, is typically equal to the mean of the original distribution. Either looking at that as a mean number of Mexican Americans or a mean proportion, where we target our original proportion of 76%. We've also got a comparable standard deviation. Here from simulated sample to simulated sample, the standard deviation of the number of Mexican American jurors is about 1.48 or 1.5. Here we had 1.48 as well. So we're seeing a very similar curve there. When we change it to proportion, we get very different numbers. We could check this standard deviation as well. Here what we would need to do is square root of PQ over N. So that's 0.76 times 0.24. Those should be complementary, divided by the N of 12. So we're saying there's about a 12.3% standard deviation, or standard error, we could say, going from sample to sample, and we do see that here as well. So whenever we want to convert something, we're typically dividing by n within that square root to do that. And the other things that we can do now is count how many of our samples, let's go back to number of successes, have a count as extreme as this one from the problem, which was talking about 6 Mexican American jurors in that sample. And here we have only, in our simulated samples, 436 out of 10,000, which is 4.36% of them that are this extreme. Now we would need to decide, is this beyond a reasonable doubt or reasonable variability, to determine that there is discrimination taking place. And oftentimes we'll refer to a level of significance, which really is another term for how much reasonable doubt are we willing to allow. If we set a very small level of significance, it will be more difficult to come up with the evidence. So if I set my level of significance at 0.005 or 0.5%, this would not be enough evidence to support a claim of discrimination. However, if I set the level of significance at 5%, 0.05, we are under that level of significance. We're sort of in a smaller tail. We're more towards the outside, and this gives us more evidence that we're outside of that usual range we would expect, probably from 7 to 11, or maybe 7 to 12, depending on our level of significance there.